The field of dermatology and melanoma is a field that is in constant evolution, and over the last 15 years, we have seen tremendous scientific advances. When I started to work in this field, we basically had no therapeutics. Patients with metastatic melanoma would die within 4 months. And with targeted and immunotherapy, we saw already incredible increase in survival. And I see that the science is advancing and it's a lot easier to do experiments and to collaborate with other scientists. And it's just an accelerating moment in the scientific world to continue making progress in this disease. Long non-coding RNAs and cancer treatment is a very interesting field. When I was doing my postdoc at Stanford in 2003, I remember that long non-coding RNAs, which they don't code for proteins, they were thought to be garbage. They were thought to be just, and then later on, we discovered that actually they are the regulators of the behavior of the cell. And especially there are many regulators of the cancer cell that completely depend on long non-coding RNAs. So basically they are the big bosses of regulation. Cancer research was making progress, but not as fast as we wanted to. So I started to focus on long non-coding RNAs to find new therapeutics. The background, the international background in science is very important. I wish that all the students want to get out of their own shell and get out of their comfort zones to study in other lands, because every single country, every single university adds secret components to the sauce. So in Vienna, I studied epithelial biology. When I went to Stanford, I started to study a lot of genetics and epigenetics. And then at UCSF, I focused with a very good group here on melanoma research. So basically, every single university added a lot of knowledge and a lot of people, because this is a teamwork. This is not a one-woman show in this case. Spartia Therapeutics is a company that started here in this laboratory. We discovered 7 very important molecules that when they are inhibited, basically the cancer cells die. This is a patent. And with this, we're going to start a company to produce new therapeutics against cancer. This is not only against melanoma, it's also colon cancer, lung, and brain cancer. So these molecules are very important for different kinds of cancers, not just melanoma. It was very difficult to start a company. We were scared. We are still scared. When you discover something in the lab, it's your responsibility as scientists to bring it out of the lab and bring it to humans and patients, because that's why you are doing this. Work-life balance, as we like to call it, in my opinion, is impossible. I know it sounds like very beautiful, but in reality, when you are a professor and you have a research lab, you see patients and you have a company, it's very difficult to have a perfect balance. That doesn't exist. The most important thing is to make compartments and to say, okay, this is the part of the week I see patients, and then you are fully dedicated to see patients. I do it at the beginning and at the end of the week. And then in the middle of the week, all the meetings, all the research meetings, all the meetings with scientists and investors occur. And then again, you close the compartment and you focus in a different thing. And you have to be very disciplined to make sure that when you are doing something, you focus on doing that. Family, very difficult. Your family has to be on board, because they know you are going to travel a lot, you spend many hours in the laboratory, and your partner and your children need to understand that you bring different things home, but you cannot be a perfect parent, the traditional parents that are 100% dedicated to their children. Melanoma research is advancing really fast, but I think the area where I find more excitement is on the area of quantum mechanics and quantum computing and pharmacology. We are learning that the antisense therapeutics and RNA and delivery mechanisms, we can make new algorithms with the help of quantum mechanics, electron density, and quantum computing research. And this is the area where we are very focused right now in the lab, because all these simulations will shorten the amount of time that the medications have to be tried in the laboratory to reach patients. When I was a child, I grew up in a family where academics was very important. The school education is very important, which is actually very important for most of Spaniards, actually. My father was an inventor who worked for Siemens, and I always wanted to invent things and be a scientist. I started to study medicine in the Autónoma of Madrid. I spent 2 wonderful years in Madrid studying medicine, but then I realized that I wanted more. I wanted to study further medicine in a land where I could have a job and I could study a different career at the same time. Coincidentally, I met these friends when I was studying English in Malta to improve my skills. And they told me, oh my God, Vienna is a great land. You can get a job and you can be a student, but also you can work and you can do a lot of things and be independent. And I thought, oh my God, that's great. All I have to do is to learn German. So when I came home from Malta, I told my parents, look, next year I'm not in the Autónoma anymore. I'm leaving medicine. I'm going to continue my studies in Austria. Obviously, they thought I was nuts, yeah? I've lost my marbles. But my grandmother said, I'll give you enough to survive 3 months. And after 3 months, you are on your own. I'm like, okay, I'm on my own. So I went to Austria, learned German in the afternoons. I got a job, and I studied medicine there. Wonderful people, wonderful human beings, and I got help by many people during this time. I did medicine, I did my PhD there. I also studied 2-3 years of engineering. And then at the moment that I wanted to start the residency in dermatology, I realized that I am capped by the amount of funding that Europe is going to have for me to develop my own laboratory and my own company. Is when I started to apply to come to Silicon Valley. This is the moment where I started to write grants. My paper was still not published, so I didn't get them. I went to the chair of my department, and I told Professor Wolf I didn't get the grants to go to Stanford, although I was accepted at Stanford. I needed about $30,000. And he said, well, okay, you didn't get the grant, but I think you're going to do very well. I'm going to write you a personal check. He opened the drawer, wrote a check for 30,000 euros. And with that money, I took my husband and my newborn, and we went to Stanford, where I started my postdoctoral study. And then I did after that, published very well in Science, Nature Medicine. And then they offered me the residency in dermatology. My boss at Stanford said, okay, you are done here. You have now to spread your wings and start your own group. And that's the moment where I got the position at UCSF to take over the melanoma program here and start my own laboratory. And that's today.